All right, welcome back. Well, this is part 2 of the video on root functions and equations. So now we're going to take a few minutes to talk about the equation side. So at the beginning here, we're just going to add in a little bit of information about fractional exponents. So fraction or rational exponents, usually the top of the exponent represents a power, and the bottom of the exponent represents a root. This is sort of a condensed way to apply both of those things at the same time. So here are some of the rules that govern fraction exponents. Maybe the most basic is number 1. 1/2 is the same as a square root. Even though we don't ever write it, because the square root takes one of two equal factors, there's a little 2 out there. And so you can think of this as a to the first power, and we're taking the square root, so the power is a 1 and the root is a 2, and that's sort of where the 1/2 exponent comes from. We could do that same pattern with any exponent on the argument, and then any root with any index, so square root, cube root, anything we want, and we can write it as a to the m over n. And I have it written two ways here because the order could be different. I could apply the power first and then the root, or I could apply the root first and then the power. Either of those can be written as a fraction exponent. And fraction exponents obey all the rules for exponents, so I can add them, multiply them, right? All those things that we use when we deal with exponents apply to these as well. Just a couple of exercises really quick to make sure you've got an idea of how this works. So in number 23, this is from your book in this section, we want to rewrite the expression with positive rational or fraction exponents. Can you see the power, and can you see the root that's happening? So we want to write this as z raised to a fraction exponent, the top being the power, which in this case is the 5, the bottom being the root. This is a cube root, so we put a 3 in the bottom. Same thing's true in number 25. The only difference with this one is we have a negative here on the outside. So any negative exponent flips what we have down across the fraction bar. Could be down, could be up, across the fraction bar, either into the numerator or the denominator. In this case, it's already in the numerator, so the negative exponent is going to move everything down to the denominator. The negative exponent is like a reciprocal, sort of like we're dividing. And then we can take that expression now and write it as a fraction exponent. Can you see the power? And can you see the root? This time the power is on the outside. That's the 3. And we're working with a 4th root. So it looks like that. This is something that may come up in this section just because we're dealing with roots. Roots can be represented as a fraction exponent, so that's why this is included. So now let's talk about solving equations. Here's some basic steps that you can use to solve an equation that has a root or a radical or a fraction exponent. We want to isolate the radical or the root. We want to raise each side of the equation to an appropriate power. That would be the opposite of the root, the opposite operation. That would sort of cancel that operation out. When we're solving, because we're raising both sides to a power, sometimes extra or extraneous solutions can pop up. And so for all of these, we do need to check our answers. This is not just let me check to see if I'm right. This is I really need to check because I might have gotten a false answer. Okay, so I've just pulled a couple from your book that I thought would be a good representative sample. This one I wrote with a fraction exponent just to give you a look at what that would look like. So just like we were working with a minute ago, this is the power, this is the root. So really this translates as a cube root of x plus 1. In this equation, the root is already by itself. So now I want to apply a power to both sides to remove the root. Since it's a cube root, I want to apply a power of 3. And I have to do that to both sides. So the cube root and the cube are going to cancel each other out. Negative 3 cubed would be negative 27. And if I subtract 1 over to this side, that's going to give me negative 28. And then I just want to do a quick check to make sure that negative 28 does work. I want to go all the way back to the beginning to plug that in. Now this 1/3 exponent is the same as a cube root. So you could represent it either way, I think, with your check. If you wanted to put it in your calculator and use the 1/3 exponent, you could. Today I'm going to use the cube root just because I think that's easier to look at. I don't really feel like we've done any big change by using this step instead of the first step. So that works out to be the cube root of negative 27. And I know that that's negative 3. So this is a good answer. Okay, let's try another one. We're going to sort of notch them up a little bit each time and do one that has a little bit different, the same process, different results, so you can see how to handle what you have. This is number 11. So this time we have the square root, but outside the square root we also have a variable. So that does change the result that we get from this same solving process. We're still going to isolate the root by subtracting 1 over to the right-hand side. And then we're still going to apply a power to both sides. Since this is a square root, I'm going to apply a power of 2. And on the right-hand side, everything on the right as a unit gets squared. On the left-hand side, the square and the square root are going to cancel each other out. On the right-hand side, we will need to FOIL 2 copies of x minus 1 together to expand that. Okay. So if I FOIL these together, I should get x squared minus 2x plus 1. Now that the radical is removed and I've kind of expanded everything, I want to take stock of what I have and think of a strategy that will work from here. Because I have an x squared, I can't just move things around to get x by itself. I actually need to use a strategy that will help me solve with an x squared. So factoring, the quadratic formula, any of completing the square, any of those things would work. Okay. Before I can do those steps, though, I need to get everything to one side. So that's what I would like to do next. I want to subtract x, and I'm going to do both of these at once. Subtract 5. And lucky for me, this looks factorable. That always makes the problem a little bit simpler. I need 2 numbers that add to be 4. Multiply to be 4 and add to be negative 3. Looks like minus 4 and plus 1. So if I set each of those equal to 0, I'm going to get x equals negative 1 and positive 4. Now, just like we did for the first example, we want to check to make sure that these work. And we want to check them individually, and we want to go all the way back to the top to do that check. So let's start with -1. So I plug in -1 everywhere where there's an x. In this case, that's both places. I get the square root of 4 plus 1 equals -1. So that's 2 plus 1 equals -1. That's definitely not working out. So -1 is out. Does not work. Let's check 4. So I have the square root of 9. That's 3 plus 1 equals 4. That works. So 4 is my only answer. All the possible scenarios could happen for problems like this. Both answers could work. One answer may work, like this particular problem, or both answers could not work, and in that case you would have no solution. All right, let's up it one more notch so you can see an even more challenging problem. This is number 13. I chose this one because it has 2 square roots in the problem. We still want to use the same process. At the beginning here, because we have 2, we're just going to choose one of the square roots to isolate and then kind of work from there. So I'm going to isolate this first square root. I'm going to get it by itself. I'm going to add this square root over to the other side. Now, just like before, because I've isolated this one, I'm trying to remove this square root. So I'm going to apply a power to both sides. And since it's a square root, I'm going to square it. And I'm going to square the right-hand side all together as a unit. On the left, the square and the square root are going to cancel each other out. On the right, I want to expand this, so I want to FOIL 2 copies of what I have together. That's going to take a little bit of work, but we can do it. Okay, so the first times the first, the outside would be the square root of x plus 1. The inside would be the square root of x plus 1. So if I have 2, I have 1 and 1, I'm going to add them together. I'm going to get 2 square roots of x plus 1. And then the last times the last, basically we'll have the square root of x plus 1 squared, which is going to give us what's inside, which is the x plus 1. Oops, I don't need that. Sorry. Okay, let's combine some like terms here. Let's see. I can at least add this one with this one. So that'll be 2. I have an x, and then I have 2 square roots of x plus 1. Okay, so this is sort of like the first step. I've isolated one square root, I've squared both sides to remove that square root, and I've sort of worked out. Now, the next goal, because I still have a square root that's in here, and I don't want that, I'd really like to have all the square roots away so that I can finish solving in sort of a normal type of fashion. So now I want to kind of repeat this process. I want to get this remaining square root alone and square both sides again. So let's do that. So we're going to subtract these things over to the other side. I'm going to subtract x, and I'm going to subtract 2. That's going to give me x plus 1 equals 2 times the square root of x plus 1. Although I could let that 2 hang out there, I'm going to go ahead and divide it. These problems with 2 square roots can be somewhat long. They can take up an entire page. Okay, so now I have that square root alone. Now I would like to square both sides. Then the square and the square root are going to cancel each other out on the right-hand side. And I'm going to have, why don't we write it like x plus 1 times x plus 1 in the top, and 2 times 2 in the bottom. 2 times 2 is 4. Okay, to move this so I don't have a fraction, I'm going to multiply both sides by 4. And I'm going to FOIL the left-hand side. Notice I have no more square roots, by the way. We lost our square root up here, which is good. So now we're just trying to solve. You may want to kind of take stock at this point now that we've expanded everything. I do have an x squared. So just like in the last example, I want to try and get everything to one side and then factor, quadratic formula, one of those tools. So I'm going to subtract the 4x and the 4. And this is where I feel, whew, I can factor this. I know what to do now. 3 and 1, -3, +1. So if I set each of those equal to 0, I get two possible answers, -1 and +3. So now I want to go all the way back to the top and check to see if these work. All right, I don't have as much room at the top this time, so I'm just going to do it on the side here. If you have the problem written down. So first I'm going to check -1. And I'm going to plug it into the original equation. To see if it works. So I have the square root of, this is -2 plus 3. So this is the square root of 1 minus the square root of 0 equals 1. The square root of 1 is 1, and the square root of 0 is 0. So 1 minus 0 equals 1. That works out. So -1 is a solution. Now let's check 3. This would be the square root of 9 minus the square root of 4 equals 1. That's 3 minus 2 equals 1. That works. So in this problem, both answers that we got are true solutions. Okay, so in this example, we had two square roots. So we needed to kind of go through the process of isolating a square root and squaring both sides 2 times. And sometimes that's the case. One more topic in this section that I don't want to leave out, because I feel like this is a good skill to have going into calculus, and that's the idea of U substitution. And so we can use U substitution, or at least we're going to use it when we have an equation that's in quadratic form. And we say that when we have a variable in the center, and then the first, or the leading term, I guess, has an exponent that's twice as big. That's how we know it's going to be quadratic form. So we're going to, instead of working with these cube roots, which is essentially what they are, we're going to choose a variable to represent this middle expression, and then when we square it, we should get the expression that we see in the leading term because the exponent is doubled. You could use any variable, but the tradition is to use a u. So I'm going to do that. So I'm going to let u be x to the 1/3 power. And so that you can see how this substitution is going to work really well for us, if I square both sides, if I square x to the 1/3 power, raising a power to a power, we multiply. You can think of this as 2/1. So this becomes u to the 2/3. So anywhere I see u to the 2/3, I can put in u squared. Anywhere I see, oh, sorry, there should be an x. Let me say that again. Anywhere where I see x to the 2/3, I can put in a u squared. Anywhere where I see x to the 1/3, I can put in a u. So this changes my equation to u squared minus u minus 6 equals 0. And this is something that looks familiar. I can solve this. Just like we were saying a minute ago, I can use factoring, quadratic formula, completing the square, whichever of those seems the most reasonable to you. I like factoring, so I'm going to always go there first. This one is factorable. I can do 3 and 2, and to make this a -1 in the middle, I can make it -3 and +2. So if I set each of those equal to 0, I'm going to get u equals -2 and +3. But my original question does not ask me about u, it asks me about x. So the second step here is to then go back to what u represents. Remember, we let u be x to the 1/3. So instead of u equals -2, I really have x to the 1/3 equals -2. And this is the same as the cube root of x equals -2. So to remove that cube root, I can raise both sides to the power 3. And the cube root are going to cancel out. So I get -8 as a solution. Okay, and then I also had u equals 3, but u was representing x to the 1/3, which is the cube root of x. And so I can cube both sides. And get 27. So these are my two answers. Okay, this is one example of u substitution. There are plenty other of this type of problem in your book. It's not always an x to the 1/3 that we are substituting for. It could be a lot of different things. But this is a really handy tool to use to help you solve. All right, well, I hope this helps you give a good idea of how it looks to solve an equation with a root. I hope you'll take some time to practice all of these things, and we'll see you in the next video. Bye-bye.